In a simple graph, must every vertex have degree that is less than the number of vertices in the graph? Why? Well, suppose we had n vertices arranged in this circular orientation. And let's assume that the degree of vertex 1 be greater than or equal to n. And the number n here represents the number of vertices on this graph. So we're specifically choosing vertex 1 to be the vertex that has degree greater than or equal to n, and we're going to arrive at a contradiction. The problem here is that when we connect the dots, v1 can be connected to v2 and v3 and v4 all the way up to vn, and this would be n minus 1 edges total. Since v1 can't connect to itself, keep in mind this is a simple graph. So if the degree of v1 is greater than or equal to n, that means that there's another line coming out of v1. And this begs the question, where does this line go to? If it wraps around and comes back to v1, that's a loop, which violates the fact that this is supposed to be a simple graph. If it connects to any other vertex, like vn, for example, then we create a multi-edge, which means that there are too many edges. And so the idea is that if we take this vertex and we connect it to as many other vertices as possible, even when we do that, we still don't have enough edges to create a situation where the degree of this vertex is greater than or equal to n. We can only get up to n minus 1. And so that's why this is impossible. Part B, can there be a simple graph that has 4 vertices, all of different degrees? Well, let's consider what are the possible degrees for this graph. Well, we could have a vertex of degree 0, which is an isolated vertex. We can have a degree of 1 or 2 or 3, but we can't do a vertex of degree 4 if there are only 4 vertices, and that's because of part A. If we had a vertex of degree 4, then we would need to connect that vertex to a 4th vertex, which means we would need to connect it to itself, creating a loop, which is a contradiction because this is a simple graph. So if all 4 vertices have different degrees, and these are the only possible degrees that these vertices can have, then that means that these are the 4 degrees in our graph. So I'm going to try to draw this graph by first drawing the number of lines coming out of each vertex. Vertex 1 will have degree 0, vertex 2 will have degree 1, vertex 3 will have degree 2, and vertex 4 will have degree 3. Keep in mind this has to be a simple graph. Now the problem here is that the degree of vertex 4 is 3, and since there are only 3 other vertices here, that means vertex 4 has to be connected to all of the other vertices. And that creates several problems. The first problem is that v1 is supposed to have degree 0, meaning that it is an isolated vertex. So that's a contradiction. The other problem is we have this extra edge on v3 that we can't do anything with now. So this is impossible. Part C, for any integer n greater than or equal to 5, can there be a simple graph that has n vertices, all of different degrees? Why? So the answer to part C is going to look a lot like the answer to part B. So here are the possible degrees for each vertex. Since there are n vertices, the largest degree that a vertex can have is n minus 1. We can't have a degree of n or higher. That's impossible. Now, altogether, there are n numbers here that are all different, and this graph has n vertices that all have different degrees. That means that this list here represents the degrees of my graph specifically. So this is what the graph would look like if I draw all n vertices starting from v1, v2, v3, v4, all the way up to vn minus 2, vn minus 1, and vn. And specifically what's important here is that we're going to assign v1 with a degree 0, v2 with a degree 1, and so forth. So in general, the degree of a vertex is going to be whatever the index is minus 1. So the degree of vertex 1 is 0, the degree of vertex 3 is 2, the degree of vertex n minus 2 is n minus 3, and the degree of vn is n minus 1. So vertex 1 is isolated, vertex 2 has 1 edge coming out, vertex 3 has 2 lines coming out, Vertex 4 has 3 lines coming out. What's important, though, is that when we get up to Vn, Vn is going to have a degree n minus 1. And altogether, there are n vertices. Vn can only connect to all of the other vertices. Since Vn can't connect to itself, that means it can have up to n minus 1 neighbors. Since the degree is n minus 1, that means Vn is connected to every vertex on this graph. The contradiction comes from looking at V1 and Vn. On one hand, the degree of vertex 1 is 0. It's supposed to be an isolated vertex. But on the other hand, the degree of Vn is n minus 1. So Vn is supposed to be connected to all of the other vertices, including V1, which is supposed to be connected to none of the vertices. That's a contradiction. And so this is impossible. Thanks, everyone, and I'll see you in the next video.